Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic algebraic expressions. In the previous video, we learned how to factorize algebraic expressions. In this video, we are going to learn how to use the principle of difference of two squares to factorize an algebraic expression. So let's begin by learning what difference of two squares are. Expressions of the form x squared minus y squared are called difference of two squares. So whenever you have an expression where the first term is a squared and the second term is also a squared, then we have the first term minus the second term. We say that we have a difference of two squares. So x squared minus y squared is just an example that was given. Another example of difference of two squares can be a squared minus b squared. That is also difference of two squared. You can also have 4 squared minus 2 squared. That is also another example of difference of two squares. Now, if you have difference of two squares, how do we expand it? If you have difference of two squares, how do we expand it? X squared minus y squared is a difference of two squared and it's expanded as x plus y in one bracket, then x minus y in another bracket. So all that this means is that whenever you have x squared minus y squared, the expansion is x plus y in one bracket, x minus y in one bracket. That is the first term plus the second term in one bracket, then the first term minus the second term in another bracket. We are going to pick some examples using this principle and see how it's used. But there are some things that you must take note of. Remember that both the first and second terms must be a perfect square. That is, it must be that term squared. And the sign between them must be the negative sign. So it must be the first term squared, the second term squared, and the sign between them must be negative. So if you have x squared plus y squared, it is not difference of two squares. For this to be difference of two squares, the sign here must be negative, not positive. Now let's pick some examples and see. Using difference of two squares, factorize the following. So we have been given I, and I. Then the second question says that find K if 3K plus 13 squared is equal to 16 squared using difference of two squares. So let's begin with the first one. We have 4x squared minus y squared. Now we can see from here that this in itself is not difference of two squares, because we learned from the previous slide that if you want difference of two squares, the first term must be square and the second term must also be a square. Then this must be negative. So the negative is there. The second term is a square, but the first term is 4x squared. The 4 here is preventing this from becoming a square. Now, to take care of that, we know that when we were learning indices, we came to see that 4 is the same as 2 squared. So 4x squared can also be written as 2 squared s squared. Then we have minus y squared. We have seen from indices that 2 squared s squared can also be written as 2x brackets all squared minus y squared. So we know from here that 4 has now been changed to 2 squared. Then we already have our s squared. We know from indices that 2 squared s squared can be written as 2x into brackets squared minus y squared. So we can now see that this is now difference of two squares, because right now 2s is our first term and y is our second term. So in this case, x has now been 2x and y is y. Remember, we said the principle of difference of two squares is that if you have x squared minus y squared is the same as the first term, which is x, plus the second term, which is y, then you open another bracket, the first term, which is x, minus the second term, which is y. So you see that if you are comparing this here, 2x is now x, we have the square here, so the square is there. The minus here, so minus is also there. Then y squared, so we have y also being y. So if you want to expand this, it's going to be the first term, which is 2x, minus the second term, which is y, in one bracket, just as we have here. We also have that here. Then the first term, which is 2x, plus the second term, which is y, in another bracket. So just as we have here, we also have that also there. So if you want to expand difference of two squares, make sure that you have the first term as a square, the second term as a square. Then it's written as the first term plus the second term in one bracket, the first term minus the second term in another bracket. You can change the positions and it doesn't matter. Remember when we were learning real numbers that we said that multiplication of real numbers are commutative. So you can change the position and it doesn't matter. Let's take the next question. 36p squared minus 49q squared, and we are supposed to use the principles of two squares. We know that 36p squared minus 49p squared, like this, we cannot use the principle straight away like this, so something has to be done. We have come to see that 36 can also be written as 6 squared, because 6 squared will give us 6 times 6, and 6 times 6 is 36. 49 can also be written as 7 squared. 7 times 7 will give us 7 squared, and know that 7 times 7 is 49. Now 6 squared p squared can be written as 6p all squared. 7 squared q squared can be written as 7q all squared. So you can see clearly from here that this is the first term, 6p. This is the second term, 6p. 7q. 6p is a squared, 7q is a squared, and we have minus here. So this qualifies as difference of two squares. You know that to expand this, what you do is that the first term, which is 6p, minus the second term, 7q, in one bracket. Then you open another bracket. The first term, which is 6p, plus the second term, which is 7q, in another bracket. Let's take another example. 2a squared minus 8b squared. Now we are supposed to use the principles of two squares to factorize this. We can see that this given to us straight away is not difference of two squares, so we need to do something about it. Now what do we do? If we factorize 2 out here, from the previous video we came to see that in this case, if you factorize 2 out, here used to be 2a squared, and you have factorized 2 out, so you have a squared, minus here used to be 8b squared. We factorized 2 out, so you need, here will be 4b squared. Remember, we've taken 2 from the 8, so yeah, we must get 4, so that 2 times 4 will give us 8. Here used to be 8. We factorized 2 out, so what will be left here is 4, because 8 divided by 2 give us 4. So we have a squared minus 4b squared. Now we can work what is in the brackets in such a way that we have a difference of two squares. So let's continue. We have seen that 4 can also be written as 2 squared. So in this case, 2 into bracket a squared minus 2 squared b squared can be written as 2b all squared. So if you look at it, we now have a squared minus 2b all squared. Remember, the second term here is now 2b. The first term is a. The first term, which is a, is a squared. The second term, which is 2b, is also a squared. They are being separated by a negative sign, so we have difference of two squares here. So in this case, if you are expanding, we know that you first bring your square bracket, because you have a bracket in a bracket, so the outside bracket must be square brackets. So you first bring your square brackets. We know that if you are writing for difference of two squares in this case, you are going to have the first term minus the second term in one bracket, so a minus 2b in one bracket. Then in the second bracket, you are going to have the first term plus the second term, so a plus 2b in another bracket. Remember, they are all being multiplied by 2, which is outside the bracket. Let's take the final example. We are supposed to find Q if 3Q plus 13 squared is equal to 16 squared. Now from here we can see that we have to group like terms. So we group like terms, we group the numbers, the terms with numbers at one side, then we group the terms with variables at another side. So you can see that we have 16 squared here, we have 13 squared here. This 3 has a kill attached to it, so we are going to bring the 13 to this side. 13 is positive here, so when it crosses the equal sign to this side, it's going to be negative. So we are going to have 3q is equal to 16 squared minus 13 squared. Now you can see from the right hand side that 16 squared minus 13 squared is difference of two squares. 16 is the first term, it's a square. 13 is the second term, it's also a square. It's being separated, they are being separated by a negative sign. So 16 squared minus 13 squared qualifies as difference of two squares. We know that to write 16 squared minus 13 squared using the principles of difference of two squares, if you are expanding it, you are going to have 16 minus 13 in one bracket, then 16 plus 13 in another bracket. So the first term minus the second term in one bracket, then the first term plus the second term in another bracket. So you are going to get 3q is going to be 16 minus 13 will give us 3. 16 plus 13 will give us 29. Now we have 3 in this bracket, 29 in this bracket, so they are going to multiply. So you are going to have 3 times 29. So 3q is going to be 3 times 29. Sorry, 3 times 29 will give us 87. Now to make q the subject, we divide both sides by 3. So we divide 3q by 3. We divide 87 by 3. 3q divided by 3 will give us q. 87 divided by 3 will give us 29. So you can see from here that we have used the principles of difference of two squares and we have been able to find q as 29. Thank you so much for watching this video. Take more examples on difference of two squares and use the principle as we used in this video. See you in the next video where we will learn how to factorize quadratic trinomials. Bye bye.